We have on your left an arithmetic sequence, and on your right is a geometric sequence. And as the name implies, a sequence is a set of numbers that follow one another. In the case of an arithmetic sequence, we add a certain amount to each number in order to continue to advance. And in a geometric sequence, we multiply by a fixed amount as we advance. In an arithmetic sequence, the amount that you add is called the common difference. And it is abbreviated by the letter D. And the common difference is found by taking a number and subtracting the number to its left. So here we would have 15 minus 11 equals 4. And on the right, with the geometric sequence, this value is found by dividing. So we're going to take this number and divide it by the number that's to its left. And this reveals the so-called common ratio, also known as the R value. So R will equal 3, and over here D would equal 4. So I remember being introduced to this concept and thinking, okay, this is pretty simple. And our teacher then went on to graph these two sequences. And I learned that in an arithmetic sequence, you would get a line with a slope that's equal to the common difference. And that made sense to me because for every one step you went to the right, the values would increase by 4, and that's the very definition of a slope. In the case of a geometric sequence, our teacher explained that these have the pattern of an exponential equation. And these graphs are going to look like a typical exponential equation, something on the order of like this, if it is a rising situation. And this b in the exponential equation format is going to be equal to the common ratio. So I remember feeling pretty comfortable with these concepts, and then all of a sudden the teacher writes down these formulas. And here is where things get confusing, and they were confusing for me when I first learned this topic. So in this video, I'm going to start out by explaining all of these symbols and letters. We've already spoken about the D, that's the common difference in an arithmetic sequence. We've spoken about the R, that's the common ratio in the geometric sequence. But I'm going to explain to you how to organize your thoughts when you look at all these symbols. Let's now turn our attention to the arithmetic sequence that we looked at before, and recall this had a common difference of 4, meaning if we subtract 11 minus 7 or 15 minus 11, we're going to get 4, and we are adding 4 as we advance from one number to the other. Now folks, when you look at a sequence like this, you're really looking at two things. You're looking at a position in the sequence, and you're looking at the value. So let's look at this number 3. This is position number 1. The 7 is position number 2. The 11 is position number 3. And those positions, those slots, are the n value. Each of those positions have a value, and that value is a sub n. I wish they used v instead of n, because that would make it more clear. When you see a sub n, they are talking about the value at a particular n. So if we look at a sub 2, the minute you see a sub 2, I want you to think about this as the value in slot number 2. So the value in slot number 2 is going to be 7. A sub 4 is the value of the sequence in the 4th position. So this is going to equal 15. Okay, so now that we've spoken about what a of n means, let's talk about this whole concept of n minus 1. You see them all over this all over in the formulas. If we look at the formulas again, look, here's n minus 1 here, here's n minus 1. What are they talking about? Here's n minus 1. What are they talking about? Excuse me. Folks, they're simply talking about relative positions. So here, if you're looking at this position number 3, n equals 3, here is n minus 1, position number 2. So when they talk about n minus 1 and n, they're just talking about what position you are on the sequence. N minus 1 simply means the position to the left. So if you're at a sub 4 and the value is 15, and you're asked what is the value of a to the n minus 1, you're going to say to yourself, okay, a sub n is position 4. I'm going to go to the position to the left. 4 minus 1 is 3. So I'm going to go to the 3 position, and that would be 11. N minus 1 simply means take one step to the left. Sometimes they're looking for the actual n value. In other words, sometimes you're talking about n equal to 3 and n minus 1 equal 2, and sometimes they want the value. So if we have the value at position 4 equal to 15, and they want the value at n minus 1, you simply take one step to the left. Okay, let's now put some of our new learned terminology to use, and let's use the first formula. This is the explicit formula for the arithmetic sequence, and suppose you are asked by your teacher to find the value a of 12. Okay, again, you see a with 12, they want the value at position 12. Okay, so you go to your sequence, and lo and behold, it doesn't go on to 12. Now, one thing you can do is just keep adding 4 and count until you get to 12, and that would be your answer. But that's a rather inefficient way to do it, especially if you're asked to find, a at position 126. So how do we do that? Well, the first thing we do is we come down here and we look at our formula. All this is saying is the value at position 12, remember, I would have liked to use the word v. They used a. The value at position 12 equals the value at position 1, namely 3, plus the common difference, which is 4, times n minus 1. So here, they're not looking for a value. You don't see the letter a here. Here they want the actual slot number. So if we're going to use n minus 1, we're going to use 12 minus 1, or 11. So this becomes the value at position 12 is going to be 3 plus 4 times 11, which is going to be 47. It's all about understanding what these symbols mean. Let's do another one. Suppose you are asked to find a 52. You see a, you think v, the value at position 52. Okay? So here they want a 52, the position in slot number 52. We're going to take a sub 1. That's the value in position 1. The value in position 1 is 3. Our common difference is 4. N minus 1, we're talking about slot numbers. There's no letter A here. This is not the value. They're looking for the slot number. And here, 52 minus 1 is 51. So when we do the math, this is going to be 207. Let's now introduce the so-called recursive formula for an arithmetic sequence. And the word recursive is Latin for running backwards. And indeed, that's what we're doing here. We're running backwards. Recall that n-1 means one step to the left. Folks, the recursive formula, despite its intimidating name, is actually simpler. Because look, if we want to find a sub 3, okay, if we want to find a sub 3, meaning we want to find the value at position 3, what do? We take the value at the position 1 to the left of it, position 2, what's that value? That value is 7, and we add the common difference, which is 11. So a sub 3 means the value at position 3 is you take the value at the position one step to the left and you add the common difference. What could be simpler than that? Okay, if we wanted to find a sub 5, a sub 5, remember, I would like you to think of that a as a v. When you see a sub 5, I want you to think the value at position 5. So if we want the value at position 5, what do? We go to the value at position 4, n-1, 5 minus 1 is 4. We go to position 4 and we add the common difference. So at position 4, the value is 15. We add 4 and we get 19. Typically, what transpires on a quiz or on your homework is you're given a sequence and you're asked to write a recursive formula. So here, our recursive formula would be, if we're looking at this set of numbers, we would say, well, to get a sub n, you go to the you go to the a to the n-1 value, and you add 4. So this is the recursive formula for our sequence. And again, typically that's how you'll be asked to use the recursive formula. Okay, let's use some of the terminology we've reviewed to do some homework problems. So here in exercises 7 through 12, we are asked to write the first 6 terms of the sequence, then graph the sequence. So we're given this information here. A sub 1 equals 0. The value at position 1 equals 0. So let's go ahead and write some members of the sequence. Here's position 1, position 2, position 3, position 4. They've given us the value at position 1 as 0. Now here's our formula. A sub n, okay, let's look at position 2. So a sub 2 means the value at position 2 is going to be the value at the position to the left of it plus 2. What's the value at the position to the left of position 2? It's none other than 0. So we're going to do this. We're going to add 2 to get a sub 2. How do we get a sub 3? We go to the position to the left of 3. 3 minus 1 would be 2. So we go to position 2. We look at its value and we add 2. And so on. Okay, so there are the first 6 members of this arithmetic sequence. Now, when they want you to graph the sequence, these are the y values and these are the x values. This is the input, that's the output. The input is what position you're at, the output is its value. So this graph is going to be a straight line with a slope equal to the common difference. The common difference is 2. Okay. So in the first position, when n equals 1, the output is 0. That keeps us right on the x-axis. At position 2, with n equal to 2, we are now at 2. The input is 2, the output is 2. Next, when n equals 3, we are up to 4 on the y-axis. 1, 2, 3, 4. Like so. So folks, this will be your graph. Notice, for every one movement to the right, we're going up 2. That is the very definition of a slope. The rise over the run. One movement to the right on your input, what is your movement on the y-axis? Let's do the next problem. Number 8. Okay, they tell us a sub 1 equals 10. The value at position 1 is 10. Let's write that down. Here's position 1. Here are the other positions that we're going to get to. The value at position 1 is 10. Here's your input, n equals 1. Value is 10. Here's our formula. To get the value at any n value, we take the value to the left. Whoops, I'm doing the wrong one. To get the value of any n value, we go to the position to the left and we get its value and we subtract 5. Okay? So to get a sub 2, what do? We take the value at a sub 1, which is 10, and we subtract 5. So here our d value is going to be minus 5. How do we get the value at position 3? Okay, we're right here now. Again, this is our n. If we're going to graph this, this is the x value. Up here is the y value. That's the output. That's the value. Okay, so now we're trying to find what the value is at position 3. Okay. Well, let's look at that. The value at position 3, right now we don't know what it is. We're going to take the value at position to the left of it, 5, and we're going to subtract 5. So that's going to be 0. What's the value at position 4? The value at position 4, to find it, we're going to take the value at the position to the left of it. To the left of it is n minus 1. To find this value, here's our new question mark. We're going to take the value just to the left of it and subtract 5. If we keep doing that, we get something that looks like this. If we were to graph this, let's do that quickly. I know that we're going to have a slope of negative 5, which means we're going to get a line that is going to be going down as we move from left to right. Our input value is 1, our output is 10. Input is 1, output is 10. Input is 2, the value is 5. Input is 3, the value is 0. We're down to the x-axis already. So you see the pattern. It's going to be a downward sloping line like so. For every movement 1 in this direction, we're going to go down 5. Again, that is the definition of a slope. Every one movement to the right, what is happening? You're going down 5. On this next problem, we are asked to write the recursive rule for this sequence. Okay, so let's look at this. Here's our positions. Here's our values. Okay, so let's write it down and see if we can come up with the recursive rule. Again, a fancy name for a simple concept. Okay, so here's position 1, 2, 3, and 4. This is our n values. Our a of n are the values at each of these positions. So our a of 1, our value in position 1, is 7. A sub 2, remember I wish that was a v. The value at position 2 is 16. And so on. Okay. In order to write the recursive rule, in order to really deal with any of these formulas, you want to know what your d value is. What's the common difference? Okay, and the common difference is obtained by taking this number and subtracting the number that's to its left. And that value is 9. Okay, so let's write our recursive rule. In order to find the value at any given number slot, you go to the slot before and you add 9. Folks, it is just that simple. If I want to find, for example, what a sub 4 is, someone walks up to me and says, what's a sub 4 in this sequence? Well, I would go to the value before and add 9. The value before, 1 to the left, is 25. I would add 9 and that would give me 34. Okay folks, continuing on with this section where they want us to write a recursive rule for the given sequence, let's jump down to number 16. Now look at the difference between 16 and the one we did previously, 13. In 16, they give you the values, but they don't give you the n numbers. That's okay. We don't need them to give us this. We know how to do that. So let me write the numbers of the sequence down first. And let's write our recursive rule. Okay. Folks, these are the a values. That's the value at the given position. And here's our positions. No big deal. These are our n values. So if we were to graph this, this is our input, that's the output. Input, output. Input, value. Value. So what do we have going on here? If we want to find the value at any given position, what do? We take the value at the position before it and we add d. Now what is d here? Well, 11 minus 3 is 8, 19 minus 11 is 8, 27 minus 9 is 8. So each time we advance, we're adding 8. So that's our d value. So our recursive formula is just a sub n equals a to the n minus 1 plus d. To get any value in this sequence, we take the value to the left and we add 8. Let's see if we can find a sub 5. See if our formula works. To find the value at 5, we would take the value to the left, which is the value at 4, and add the common difference, which is 8, and we get 35. Okay, let's now turn our attention to the geometric sequence, which, recall, is a sequence of numbers where you are multiplying by something as you progress from left to right. So here, the first thing we need to do is find the so-called common ratio. So we take a number and we divide it by the number that precedes it. 6 divided by 3 is going to give us a common ratio of 2. This is the number that we're multiplying by. Again, the terminology is confusing. this is the number we're going to multiply by as we advance. We have to get that number in order to work with these formulas. Okay, but the rest is just the same as with the arithmetic sequence. A sub n means the value at position n. A sub 1 is the value at position 1. R is the common ratio, which you determine by dividing a number by the number that precedes it. And you take it to an exponent that's one less than the position that you're looking for. So n minus 1 is going to be a number. That's a slot position. Value, value, slot position. Okay? So let's see if we can figure out, using this information, what a sub 3 would be. Okay? So to find a sub 3, what is a sub 3? What is the value at position 3? Okay, I didn't write the positions in. Let me go ahead and do that. Let me put my times 2 up here. And I'm going to put my positions underneath. These are the n values. Position 1, 2, 3, 4. If you're asked for a sub 3, what is the value at position 3? Okay, what do we do? Well, if we want to find a sub 3, we're going to take the value at position 1. The value at position 1 is 3. Then we're going to multiply that by the common ratio raised to the n minus 1 power. Okay, we're looking for 3, the value at position 3. Therefore, we're looking at 3 minus 1, or 2, as an exponent. Now, folks, very important when you do this calculation, when you evaluate this, remember PEMDAS. Exponents comes before multiplication. So you want to go ahead and do the exponent calculation first. So you could see we got 12, and that matches our data. The value at position 3 is 12. Okay, what if we want to find something that's not on the screen? What if we want to find what if we want to find a sub 5? We don't have that on our list up here. A sub 5 means what is the value at position 5? So what would be this value? What would be that question mark right there? Okay, how do we find that? A sub 5, the value at 5, is going to be the value at position 1, which is 3, times the common ratio, 2, raised to the exponent that's 1 less than the position you're looking for, 4. 2 to the 4th power is 16. 3 times 16 is 48. And indeed, 2 times 24 is 48, so they match. Okay, let's look at the recursive formula. Again, despite the intimidating sounding name, this is easier. Look, if you want to find a certain value at a position n, what do? You go to the value of the position right before it, which is n minus 1, and you multiply it by the common ratio. What could be easier? So if I want to find a sub 6, okay, which isn't here, let's give it a different colored question mark. We're at position 6. If you're asked what is a sub 6, and you want to use the recursive formula, what do? You take the value, if you're asked to find the value at position 6, what do? You take the value 1 position to the left. Again, when you see A, think V, value at n minus 1. What's the value at n minus 1? Well, we knew that was 48 from the last exercise. So you take 48 and you multiply it by 2, and that gives you 96. Don't be intimidated by the recursive formula. It is simpler. Okay, let's return to this section of the homework where we're asked to list the first 6 terms of the sequence and then graph it. So before, I conveniently skipped over the geometric sequences. I knew these were arithmetic because look, to get the value at a sub n, the value at position 1, you go to the position before it and you add. Position before it and you subtract. Look at this. Here, to get the value at a given position, you go to the position right before it, which is n minus 1, and you multiply by 3. So now I know that this is a geometric sequence, and I know that's my common ratio. That's the number that I'm using to jump to the right as I progress along the sequence from left to right. Okay, so they tell us what a sub 1 is. They tell us what the value is at position 1. Okay, and we're asked now to find the values at the subsequent positions. Okay, so let's go ahead and put our position numbers in here. These are the n values. Okay, this is the input. When we go to graph, this is going to be our input, and the values up here are going to be the output. Okay, what's the value at position 2? Well, if we want to find, let's put a question mark there. If we want to find the value at position 2, here's our formula. We multiply 3 times the value one position to the left at n minus 1. What is that value? 2. Therefore, the value at position 2 is going to be 6. How do we find the value at position 3? There's our question mark now. Let's look at our formula. To find the value at position 3, we take our common ratio, 3, and we multiply that by the value one step to the left. What's the value in the position that's one lower? It's 6. Right? Here's where n equals 2. We're looking for the value where n equals 3. You look at the value where n is 1 less. The value when n equals 2 is 6. That's what you multiply by. And this becomes 18. And if we keep going, multiplying by 3, okay, that's enough right there. And if we go to graph this, folks, the graph is going to look entirely different. It's going to look exponential. It's going to move really fast. So these are our inputs. Okay, these are our n values. They advance by 1. These are the positions in the sequence. Now we graph the values on the y-axis. First value is 2. Next value is 6. Next value is 18. Next value is 54. And this thing skyrockets like that. That's what these things do, the exponential equations. Okay, let's do another one. Again, if I'm looking for geometric sequences, I'm looking for where multiplication is going on. Okay, let's jump down to this one right here. A sub 1 equals -7. That is the value in position 1. The formula they give us is we're going to multiply -4 times a to the n minus 1. This is the recursive formula. So simple. Okay, let's write down the first 6 members of the sequence. Okay, let's write our positions in. So important to understand that the n equals the positions. Now the values, a of n. What's the value at position 1? They tell us it's -7. Now, how do we find the value at position 2? Let's put a question mark there. Okay, what is that value? How do we find it? Well, here it is right here. We take -4 and we multiply it by the a value one position to the left, -7. That's going to give us 28. Positive 28. Very important. Okay, how do we find a sub 3? And I realize, folks, we can just keep multiplying by -4 here. Okay, I realize that, and keep going. But I want you to get comfortable with the formula. I want you to get comfortable with the terminology. Okay, so let's find a sub 3. A sub 3, okay, there's our question mark. What is that value? The value at position 3, according to the formula, to get that, we're going to take -4, and we're going to multiply that by the value at the position located to the left. Positive 28. So that's going to be, I believe, -112. Okay, so we'll replace the question mark with -112. Okay, and so on. So when you go to graph this one, this graph is going to look different. This graph's going to look something like this. Okay, at input 1, we're at -7. At input 2, we're at positive 28. At input 3, we're at -112. This type of graph is going to oscillate and get bigger, like so. Okay, continuing on with the homework assignment, we're asked to write the recursive rule for these sequences. Okay, let's do number 14. Okay, what do we see here? Here's our positions, 1, 2, 3. Here's our values. A at n, a sub n means the value at position n. So here's our a sub 1, the value in position 1. Here's our a sub 2, the value at position 2. So if we want to write a recursive rule, a general rule to find a sub n, we're going to take our common ratio and multiply that by the value of the position just to the left. What is our common ratio? To get that, we take 24 and we divide it by 8, and we get 3. Therefore, our recursive rule is going to be a sub n equals 3 times the value at n minus 1. What could be simpler? What's the value at 4, position 4? Okay, to find the value of position 4, we take 3 and multiply that by the value at position 1 to the left, which is 3. So we would do the position at, the value at position 3 is 72. 3 times 72 is indeed 216. Let's look at this one down here. Okay, here it looks like our ratio is decreasing. A fraction. How do I know that? Because we're decreasing. Now when you're in a situation like this, you're looking for a common ratio, work with the smaller numbers. Okay, so 3 divided by 9 is 1/3. 9 divided by 27 is 1/3. So our R value is going to be 1/3. Our recursive formula is going to be, for a geometric sequence, a sub n equals 1/3 a to the n minus 1.